Right, my dear. So today we're going to discuss about difference between dry compression and wet compression. First of all, you need to understand what is dry compression, what is wet compression. So this concept is hidden inside the TS diagram. So to understand this concept, we need to draw TS diagram first. Then I can make you understand what is dry compression and what is wet compression. And then I will share with you what are differences, what are benefits of having dry compression and what are demerits or disadvantages of having wet compression in VCRS cycle. So we're going to draw temperature and entropy diagram. So we are taking S as x-axis entropy, y-axis temperature. So this is it. So this is draw again to make sure or to keep these things in your mind every time you have to practice. Okay, now here inside this we are having wet compression, because here we got vapor plus liquid, this side we got only liquid, this side we got only vapor. So inside, if compression is taking place from here to here, if compression will start from here, this point, this is known as dry compression. And if compression will start from here, anywhere from here inside this is known as wet compression, because we have wetness inside this. That's why we consider here X dryness fraction, which is lies between 0 to 1. Maybe you have studied about it in 12th class. Okay, now let's move to the next step. So what is it? Why dry compression is most important? And this point is also known as Hg, and here we got X dryness fraction. So basically to find out enthalpy, here we consider dryness fraction, then we go for further steps. Okay, that is different thing. So here we got HF, and here another thing, enthalpy of gas is always greater than enthalpy of liquid. Remember this term, this is most important, my dear. Now what is happening if there would be wet compression? If there would be wet compression, suppose that compression will taking place from here, one dash. Okay, so now as we know, a refrigerant effect is equal to what? H1 minus H4. Now if there is dry compression, then refrigerant effect would be like this. If there is wet compression, then H1 dash minus H4. So which one is more, first one or second one? Obviously first one is more than second one. So this is the difference between dry compression and wet compression. That means if we have dry compression, then we'll have more refrigerant effect. Okay, now let's move to the next step. What is happening with the wet compression? Basically, if there would be wet compression, then we cannot compress, basically what we are doing, we are compressing refrigerant. We cannot compress refrigerant properly if we have wetness in the refrigerant, if we have wet compression. So again there will be a problem for COP. If we have dry compression, then we'll have more COP. If we'll have wet compression, then we'll have less COP. So another demerit of having wet compression is, if there will be wet compression, it may wash away lubricant we have inside the compressor. That will cause wear and tear inside the compressor. Again, that will decrease the life of the compressor. So that's why we always think about to have dry compressor. I hope you understand the concept. This is most important, my dear. You need to understand from its root. Well, thanks for watching. Hope to see you again in my next video. Bye bye.